Hello everyone and welcome back to NotesNaka. We were talking about the applications of morphological operations, and in this video we will talk about other ones, and one of them is region filling. Region filling basically means if you have an image with some boundary like this, you want to fill it and make it something like this. So it is very opposite, exactly opposite of boundary extraction, and this is the type of structuring element that we use, something like a cross. And this is our formula, and this formula is similar to that of extraction of connected components. So xk is equal to xk minus 1 dilation b intersection of a complement, and k can be anything from 1 to 3, and we do this process until xk is equal to xk minus 1, until these two become equal. And initially x naught is taken as p, that means our image, and any value that has a value 1, it is taken with only that pixel. So that is our p. P is the point inside a connected component, and it applies the same for region filling. So and similarly in extraction of connected component, the only thing that changes is intersection of a. Here we are doing with intersection of a complement, and here only with a. So this was all about extraction of connected component. Now let's talk about thickening and thinning. So thinning reduces the binary valued image regions to lines. It is used to reduce the image components to their essential information for further analysis. Thickening is changing a pixel from 1 to 0 if any neighbors of the pixel are 1. So thinning and thickening are very self-explanatory. Thinning just means to thin the image, and thickening means to thicken the image. Thickening and then applied thinning gives us fills undesirable holes, and thinning and then thickening determines isolated components and clusters. So mathematically, thinning is A, thinning B is A minus A hit miss B. This is hit miss operation, and B is the structuring element, and there are 8 of the structuring elements that we use. And at the end what we do is A thinning B basically means A thinning B1, and then with B2, then with B3, and so on. And how are these structuring elements defined? So this is our B1. We have 1 1 1 x and x. And for B2 what we do is just rotate it in this order. So we have this x will come over here, and all of this will go this side. So we have x here, 1 1 1 x. Again for B3 we will rotate it like this, and our x will come over here, and 1 1 1 x, and so on. We have 8 of them that we have to do for our entire thinning. Then we have thickening. It is exactly the same as thinning. The only thing that changes is the formula, that is A union A hit miss B. Here we were doing A minus A minus, and here we are going to do A union. So that is all about thickening and thinning. The next one is convex hull. Given a set of points in a plane, the convex hull of a set is the smallest convex polygon that contains all the points in it. So if we have many points, then convex hull basically means to accommodate all of this point into the smallest polygon that is possible. So that is convex hull. In this one we used 4 structuring elements, and our structuring elements are something like this. We have 1 1 1 0 and x. In the B2 what we do is just shift it upwards, so we have 1 1 1 1 0 x x x. In B4 we shift it downwards, and B3 we shift it sidewards. So these are our structuring elements used, and the formula is x of k power I is x of k minus 1 hit miss bi union A. So basically what we do is, in our first one, so we have I can be 1 2 3 4 only. We have 4 structuring element, and k can be anything from 1, starting from 1, and it can go till infinity. So and x naught is our original image. So what we do is x1 we are calculating for k is equal to 1, and this is our structuring element I is equal to 1, then x11 is equal to x naught hit miss b1 union a, not because k minus 1. Our formula is x k of I is equal to x k minus 1 hit miss bi union a. So similarly we do it for x2, now k becomes 2, and we do it till xk1 is equal to xk minus 1 1. So we will have xk1 over here. Similarly we do it for k is equal to 1 again and I is equal to 2, and we do it till this condition, we will have xk2. Similarly we do it for 3 and 4, and at the end xk1 xk2 xk3 xk4, all of this will be union together to get our final convex hull. So this was all about convex hull, and at the last I have skeleton. Line representation of an object that is 1 pixel thick through the middle of the object and preserves the topology of the object. So if this is our object, then skeleton will basically mean finding out the 1 pixel value that represents that image. This is also very important thing in digital image processing, and we have to do it a lot of times as well. So this was all about morphological image processing. There are many other ways to do as well, and if you want to learn everyone in very detail, then please check out the NPTEL lectures. They have really given all the insights and all everything in a very deep manner, and if you want to learn it that way, then please check out their video. And if you liked our video, then please give us a thumbs up, also subscribe to our channel, and please share it with all your friends who might need this as well. And we will see you again in the next video. Till then, take care and bye bye.